this video clip, we want to use the Cramer's rule to solve the linear equation. And here, for the first example, we want to be a little bit aware is in front of y, the coefficient is really 1. It's not 0. Previously, we have calculated determinants. And here we need to calculate 3 determinants. Then we should be able to find out the solution of this linear system. First, we need to find out D. This one is 2, 5, 3, 1. Is from here 2, 5, 3, 1. And this is called coefficient. The coefficient matrix. So we have a coefficient matrix, which will be 2, 3, 5, 1. Okay, so then we will have a cross multiplication. Is like that. Is 2 times 1 subtract 3 times 5. That's 2 minus 15, which gives us negative 13. That's the first determinant. Okay. Now, in order to find out the solution for x, we need to replace this column, x, 2, 3, this column, by 19, negative 4. Okay, so then you may want to calculate dx, just to replace this column, first column, that's 19, negative 4. The second column, you are not going to change it. That will be 19 times 1, subtract negative 4 times 5. What do we get is 19 plus 20, which is 39. Okay. Then we got to replace the second column, 5, 1, by 19, and then negative 4. Okay. So then let me write here, dy will be keep 2, 3, and then here will be 19, negative 4. Then you do 2 times negative 4, subtract 3 times 19. What do we get? Negative 8 minus 57, which gives us what? Which gives us negative 65. Okay. Now, then we can find out the solution for x and y. So x will be calculated like dx over d, which is 39 over negative 13. 39 over negative 13, which is negative 3. Okay. What is y? Y will be dy divided by d. That's negative 65 divided by 13, negative. Okay, so is that 5? Yeah. 65 divided by 13 is 5. Negative, negative. You have a positive. Okay, so the solution really from here you have is negative 3, 5. That's the solution. Is this really the solution? You may check it. X is negative 3, y is 5. Plug in right here. Okay. Here you plug in will be what? Negative 3. Here you plug in is 5. So you will have what? You will have is negative 6. 2 times negative 3. And then plus 25. This will give you what? 19. Okay. So this is check. Well, you do not have to check, but if you want, you can check it. Okay. So that will be the solution for the first one. You can put in the second one and check. 3 times negative 3 is negative 9. Negative 9 plus 5 is negative 4. Here is negative 9 plus 5, negative 4. Okay? That's the first one. So let's do the second one. Second one is the same thing. So let's work on that. Step 1, find out D. D, this determinant is 4, negative 7, 2, 5. And then you should have a 4 times 5, subtract 2 times negative 7. And then you should have a 20 plus 14, which is 34. Now, let me write better. 34. Then you calculate dx. Dx is replace the first column with constants. So you should have a 5, negative 3, and then here is negative 7, positive 5. Again, 5 times 5, subtract -3 times -7. That's 25 minus 21. It gives us value, this is 1, gives us value 4. So you can immediately from here to find out x, which is 4 over 34, which is 2 over 17. Okay? Now, then you do is to find out dy. dy is the same. Replace the second column with 5 -3. So you keep first column 4, 2. And then the second column will be 5 -3. 4, 2 you keep it, and 5 -3. So you will do 4 times -3, subtract 2 times 5. That will be -12 minus 10, which is -22. And then you have a y value is -22 over 34, which is -11 over 17. So what's the solution from here? From here, you shall have an x value, which is 2 over 17, y value, -11 over 17. So that's the solution. Okay. You can see right here, 34 is always the denominator. Okay. 34 is always the denominator. If d is 0, denominator cannot be 0. Then we cannot use Cramer's rule. This will be the example, the last one. So you will see 2, let me write d first. D equals 2 -3, 6 -9. And you can see 2 times -9, subtract 6 times -3, you shall have a -18 plus +18, you have a 0. Okay, then it tells us what? It tells us that Cramer's rule is not applicable. Okay, Cramer's rule is not applicable, so we have to use a different approach to do that. Okay, But right now, we are designated to use the Cramer's rule. If we are not going to, if we cannot use that, we just say, okay, Cramer's rule is not applicable. Okay? All right. I'll see you next time.